So in the last class, we discussed about nuclear power plant, the main components. Just I repeat 1 or 2 minutes, then I'll start a new topic. The main components we discussed, that is the plant layout or the nuclear power plant layout we discussed last time. So that is nuclear, just the reactor part, reactor core, coolant, steam exchanger, steam. So like that we discussed. So the main part here in a nuclear power plant is reactor core. So here therefore next we'll see the main parts of reactor core. This is the main parts of reactor core, and we discussed different parts of reactor core and their functions. So just I repeat 1 or 2 minutes. So see here, this is the reactor control rod, the fuel rod. It is made up of uranium-235 or plutonium-239, and when we bombard it with neutrons, it will fission reaction will take place. So again, the moderators are used to control the chain reaction, are used to reduce the speed of neutrons, and control rods are used to or maintain the chain reaction, or it is used to shut down this plant. So reflectors are used. The function of reflector is if any of the neutrons are going away from the reactor.
The PDF is not open.
SS?
PDF is not open, sir.
It is open, no? It's not.
No, sir, it's not visible.
It's not opened only.
PDF is not open.
Close
1 minute, I'll just.
close go back here.
PDF is not.
This one, close it. Close it. ಇದು ಸೇವ್ ಮಾಡಿ ಮತ್ತೆ PDF.
Okay, take from this one.
ಮತ್ತೆ ಬರೀತಾನೆ ಇದ್ದಾನೆ.
Now, can you see the PDF now?
No, sir.
No, sir.
PPT no ಇದೆ. Photo ಇದೆ.
Photo, not seeing anything. Okay.
No, sir.
Diagram ಅಂತ ಹೇಳಿ.
Diagram, which is reactor core diagram, is not showing.
No, sir, it's not open. Icons are visible.
Okay, 1 minute. Now?
Yes, sir.
Yes, sir.
Now you can
Yes,
see.
sir.
Okay.
Now it came, sir.
Okay. Don't write on the screen, no? Somebody is writing. Why you people doing like that? Just don't write. Just say, okay. Now it is visible.
Guys,
Yes, okay. So in the last class we discussed
Disable it.
SS.
You can stop people doing that, sir.
So what is the option for that?
give come click ಮಾಡಿ
Wait, share. Somebody is writing again.
ಮತ್ತೆ ಇವರು
Remote control thing, but
Jay Punit use 8. Jay Punit use 8.
different parts of reactor. So this is a field rod made up of uranium 235 or plutonium 239, and moderator is used to control the speed of neutron. Just remember the function of all
Network problem.
okay.
ಇಲ್ಲ ಸೇರ್ ಆಗಿಲ್ಲ ಡಿಸೇಬಲ್ ಆಯ್ತು ಅವರು 1 ಸೆಕೆಂಡ್ ಶೇರ್ ಮಾಡಿ ಶೇರ್ ಆಗಿಲ್ಲ ಮ್ಯಾಕ್ಸಿಮಮ್ ಮಾಡಿದ್ರು ಶೇರ್ ಮಾಡಿ ಶೇರ್ ಮೋರ್ ಅಂತ more disable participant annotation okay click ಮಾಡಿದ್ವಿ
Okay, now the moderator, just remember the function of reactor core. It's very important. Most of the time they lacks very important. If you understood this working of this each equipment function, if you know, then we can understand the next topics. Otherwise it is difficult. So moderator function is to control the speed of neutron. So when you bombarded with field rod and neutron, it takes a fission reaction. So when the fission reaction takes, it release number of gamma rays, number of beta rays, and along with fragments, that is nothing but nucleus and neutron. So then again you want to take chain reaction, next fission reaction, again we require neutrons. So that if the neutron speed is more high, you won't get the neutrons to get the to restart the reaction. So therefore moderators are used to control the speed of neutron. So it is made up of water, deuterium, helium, graphite. So this is the moderator function. And the next very important third is control rod. So control rod is made up of cadmium to control the chain reaction in the reactor. So it will control the chain reaction, and it is helps to whenever you want to set down, it will remove the total all fuel rods from the reactor. And the reflector function is whenever some of the neutrons, if they escape from the reactor core, so those neutrons will be sending back to the reactor. So that is the function of reflector. And this is the sealing. So it is made up of concrete or cement, something to cover the or protect the reactor. So these are very important. So the coolant, the function of coolant is to extract the heat from the reactor core. So coolant, maybe it is He or carbon dioxide. So these are the very important topics of nuclear power plant. So next we will discuss about different what are the factors to be considered while selecting nuclear power plant. So factors to be selecting for nuclear power plant, just see the first availability of water. So water is required to generate steam. So water should be there. So for generating steam. The second point, distance from the populated area. So distance.
PDF went, sir.
Yes.
PDF is not visible, sir.
Okay, 1 minute.
No.
1 minute, I'll do it.
ಕ್ಲೋಸ್ ಮಾಡಿ ಇಲ್ಲ ಅದೆಲ್ಲ ಕ್ಲೋಸ್ ಮಾಡಿ ವಿಡಿಯೋ
This one. Share ಮಾಡಬೇಕು ಇದು.
ನೀವು ಅಲ್ಲಿ ಶೇರ್ ಮಾಡಿ.
Now, can you
No,
see?
sir.
No.
No, sir. No, sir.
Wait.
ಶೇರ್ ಮಾಡಿ PDF. ಕ್ಲಿಕ್ ಮಾಡಿ ಶೇರ್.
Now.
Now it came.
Yes.
Okay.
Yes, sir.
The next topic is just introduction part. We discussed what are the parts of nuclear reactor. So next topic is factors of selecting site for nuclear power plant. What are the factors to be considered, as we discussed in nuclear thermal power plant and hydro? The same thing here, factors to be considered. So water, availability of water is required. Is it? So water is required to generate steam. So the ample quantity of water is required to generate steam. So the water is very important. The next, distance from populated area, because it is a very harmful nuclear radioactivity release. So because of that, the power plant, it should be away from the populated area. Next, disposal of waste. So after the very important here, disposal of the waste produced in nuclear power plant station is burning fuel, so it will be having radioactivity element. So we should dispose the waste very carefully. That is very important, and we require a proper place for disposing of waste in nuclear near to power plant. So next, nearness to the load center, that is the distance from the load center. Again, we discussed in hydro power plant and thermal power plant the same thing. So it should be near to the load center. So then we can reduce the power losses in transmission. Then we can increase the step up with less rating of transformer. So accessibility of, that is the accessibility of rail or road. Whenever you want to construct a power station, it should be accessible with the transportation. Then we can carry our transportation is very important. These are the very important. But here the required thing, disposal waste and it should be away from the populated area. These are the two very important factors should be considered. So in nuclear power plant. So what are the reaction take place in when you consider nuclear reaction? So there are 4 different reaction takes place with the help of nuclear. There are 4 types. One is inelastic scattering, elastic scattering, neutron capture, fission. But in which reaction they use in nuclear power plant is they use fission reaction in the nuclear power plant. So we'll discuss about fission reaction. What is the fission reaction? All of you know that whenever the nucleus, neutron collides with nucleus, so that is called fission reaction. Fission is the process that when you bombarded with a neutron with a nucleus, it gives heavy atoms, causing original value splitting into 2 or more nucleus, or that is called fragments. So that is called a fission reaction. So when you bombarded a neutron with a nucleus, it release unequal fragments. So that is unequal nucleus along with neutrons, along with gamma and beta particles. So that is the radioactive elements. So that is called fission reaction. That is the fission reaction is nothing but bombarding a neutron with a nucleus. So that is the nucleus is splitting. One heavy atom is splitting into 1 or 2 more atoms. That is called fission reaction. When that process, kinetic energy, fission has kinetic energy, so that it release more amount of heat. That is in reactor. So you can see the diagram. So here uranium-235 is the natural available fuel for nuclear power plant. Uranium-235 natural available. So but naturally available, that is only 0.7% is available on the nature. On this earth it is available only 0.7%. So but it is a fissible material. That means a small when you easily it will break. So when a neutron, when bombarded with uranium-235, it gives a prompt gamma rays, it gives fission fragments, neutron, fission fragments, again prompt. This it gives one or two fission fragments, and along with neutrons, along with this, it will generate gamma, and that is a radioactive material. So that's why nuclear power plant is more careful. They'll take, because they release radioactive elements. So the fission fragments is nothing but the part of uranium-235. Uranium-235. Again, here only one neutron is there, but we'll use one or two neutrons here from neutrons. So this process, again, this neutron combined with this fission fragment, that is again uranium-235. When again this process will continue. So that's this neutron again is bombarded with this, again it will split again two or more neutron along with gamma rays, along with beta rays, again fission fragments. So this chain reaction will continues. So this reaction will continues in the reactor. So that reaction continuation, fission reaction continuation, that is called chain reaction. So because again we discussed about moderator, is it not? So suppose this neutron speed is more high and is not contact with this fission fragment, then it won't take here fission reaction. That's why the moderators are used such that the neutron speed is reduced, so it can contact with the one of the fission fragment. So that helps in generating what fission reaction. So suppose if you don't use moderator, suddenly this neutron will escape, will come out from the reactor core. So there is no, again there won't take fission reaction. So to take fission reaction, neutron speeds are reduced with the help of moderator. The function of moderator is to reduce the speed of neutron, so it can contact with the near fission fragments. So it will help take the reaction, the chain reaction. So this this continuously happens. So this is about fission reaction. When fission, what is the fission reaction? Nucleus, when neutron bombarded with uranium-235 one atom and gives continuation, that is a fission reaction, splitting of one nucleus. So next, what is a nuclear fusion? Fusion is nothing but the fission and fusion. Nuclear fusion is what? It is a combining of two or three nuclear atoms. It become, in nuclear fission, it is splitting of one atom to number of same atom, but here fusion is combining two or three atoms. So that is called nuclear fission. So it takes in stars or sun, that is the nuclear fusion reaction takes place, nuclear fission. So it's also generate energy, but electrical is well, that is complicated to collect. So that's why they use nuclear fission reaction in nuclear reactor. So the comparison between fission and fission process is very important. So just go to that. When when heavy unstable nucleon is bombarded with neutron, the nucleus splits into fragments. So that is called fission reaction. Some light elements together, they combine together, that is called, when combining they'll release energy, that is called fission reaction. So nuclear reaction is residential problem is great, residual problem is less in fission reaction. Amount of radioactive material is in fission reaction is high, amount of radioactive material in fusion reactor is less. Fission reaction is health hazard is more, but health hazard in fusion reaction is less. So that is raw tensible material is not available in plenty, but reserve, that is plenty of availabilities. So the chain reaction. So all of you understood what is the meaning of fission and fusion reaction. Now the chain reaction. The chain reaction is nothing but continuation of fission reaction in the reactor. So that is called chain reaction. That is a multiplication. You can say that. The chain reaction is the process in which number of neutrons keeps multiplying rapidly during fission. So till the whole fissionable material is disintegrated. So here chain reaction, so it continuous process of fission reaction in the reactor core is called chain reaction. The condition of chain reaction should be that neutrons should be available. If neutrons are not in the available, then the chain reaction it won't take place so rapidly. So until the fissionable material available in the reactor core. The fissionable material is nothing but nucleus fuel. Nucleus fuel, that is uranium-235 or plutonium-239 or the some of the fissionable material. So the chain, what is the condition of chain reaction here? Just see the diagram I'll show. So this neutron, first case, when bombarded with its speed 2 or 2 neutrons, it continues chain reaction. So to take chain reaction properly in the reactor core, the condition is that there is a factor K, it should be greater than 1. That means the number of neutrons in any particular generation divided by number of neutrons in the preceding generation. So that means when you take the fission reaction first case, only 2 neutrons are available. Then the next stage fission reaction, neutrons should be more than the previous one. Then only chain reaction will continuously takes. The number of neutrons in any particular generation divided by number of neutrons in the preceding generation. The K if greater than 1, chain reaction will continue. Other if K is less than 1, chain reaction cannot be maintained. Thus, if you want to maintain chain reaction constantly in the reactor core, the neutrons should be available. That means if you want to fission reaction take place in the next stage, then neutrons should be available. That's why the moderators are used to control the speed of neutron. If you don't control the speed of neutron, what happens if neutrons won't available, then is less than the previous one, so chain reaction we can't maintain properly. That's why the condition is number of neutrons in any particular generation divided by number of neutrons in the preceding generation, that the K should be greater than 1 for every chain reaction. Then only chain reaction continues, it takes the graph. So see here, this is the neutron, only 1 neutron, here 2 neutrons splitting. Again this nucleus bombarded with 2 neutrons here, 2 neutrons. Again this neutron is bombarded, again 2. So multiplication, the neutrons number should be more compared to the last one. So then only the chain reaction takes place. This is about chain reaction. So nuclear fission, and we discussed nuclear fission reaction, what are the factors to be considered, okay, and for nuclear power plant. So these are the topics discussed today, but write down all of you the based on this, okay, based on this this is a basic concept. So there are 8 nuclear reactors. There are 8 nuclear reactors. The one is a water boiler water reactor, boiling water reactor, can-do reactor, gas cooled reactor. So we'll discuss, if you study all those 8 reactors, that completes what you call third model. So just I'm going very less slowly. So if online it will complete soon. So that's why this will take only 1 or 2 topics every day in the regular class. So any doubts? Any doubts?
No, sir.
Understood the concept. All of you just do one thing, don't sit simply, write down the important what is the function of each equipment. The main thing, if you understand the reactor function, that is, I'll just once again what is the this reactor core equipment functions, then you can easily understand the other thing in nuclear power station. So just once again I'll do it, repeat. So this is very important here. This is only this part is very important. This is a very important. So reflector, why do you use reflector? Why do you use moderator? Why do you use control rods? Why do you use, that is a control seedling? This is the seedling part. So why do you use coolant? So if you understand this, then only you can understand the next topics. Because based on type of moderator used, based on control rods used, based on coolant used, the reactors are classified. There are 8 different types of reactors. Okay, so understand, all of you, just very important, what is the fuel rod, what type of fuel rods are used, uranium 235 or plutonium 239. So plutonium 239 is not available naturally, that is a man-made uranium atom. Okay, so with the help of uranium 232, so that is the reaction takes place. So moderator, it is there depending upon what type of moderator used, what type of coolant used, and what type of control rods. Based on that, reactors are classified. There are 8 different types of reactors. We'll study in the next class, 2 or 3. So 2 class. So if you study that, the nuclear, one more topic, how do you control the nuclear reactor disposal waste? That's important. So 3 class, it will complete model 3. Okay, any doubts? So all of you just go through gas and diesel power plant notes, and just I'll send the assignment questions. All of you write the assignment. When the college start, you need to submit hard copy. Okay, so what are the portions we covered till now? I'll just put a assignment in the group or Zoom Google class. So all of you just write the assignment, and whenever the college start, during that time you need to submit hard copy of that. So very important. If any doubt, you can ask question. Is it clear today's topic?
Yes, sir.
Yes, sir.
Okay, so tomorrow I don't have any class, is it not? Regular class only will take. So there are 8 different types of reactors. If you study, almost 80% of the syllabus will be over. So 2 days, 3 will study, 3 or 4 reactors will study. Very important. Is it clear? If you have any doubt, you can put a question, no problem. And the same thing, what I do, I'll send the study material in the Google class. You can download that. Okay. You can download that. So we'll meet in the next class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Hi, sir.
Thank you. Bye bye.